Tin tức đáng chú ý nhất về bệnh lý cơ xương khớp. Bệnh cơ xương khớp có thể gặp ở bất kỳ độ tuổi nào, nhưng phổ biến nhất là với người cao tuổi. Ngoài hậu quả trước mắt là gây đau đớn, cản trở đến cuộc sống sinh hoạt hàng ngày, bệnh còn có thể gây ra nhiều biến chứng nguy hiểm như là teo cơ, biến dạng khớp, dính khớp, giòn xương, thậm chí là có thể gây tàn phế suốt đời. Minh chứng là rất nhiều bệnh nhân hiện đang phải sống khổ sở mỗi ngày vì căn bệnh cơ xương khớp. Câu chuyện của nhân vật ngay sau đây sẽ là một ví dụ điển hình.
Đau nhức khổ vô cùng, cả đau như thế thì cô nghĩ rằng cô chết đi còn hơn cô sống.
Ở tuổi 64 tưởng chừng sẽ được sống vui vẻ, quây quần bên con cháu, nhưng cô Lê Thị Hiền tại Chương Mỹ, Hà Nội lại phải đối mặt với những cơn đau nhức triền miên do viêm đa khớp nặng. Các cơn đau cứ liên tục hành hạ cô ngày lẫn đêm. Chân phải của cô bị teo, chân trái bị sưng tấy khiến cô không thể hoạt động đi lại như người bình thường. Mọi công việc đồng áng đều phải dừng lại để nhường chỗ cho những chuỗi ngày điều trị trong bệnh viện. Suốt 17 năm dòng dã, cô đã quá quen thuộc với các bệnh viện và những lần hút dịch khớp đau thấu xương. Cô cũng đã thử thêm mọi cách từ đông tây y, các loại thuốc lá, thuốc nam nhưng đều không đem lại kết quả khả quan. Từ khi cô bị bệnh, gia đình đã khó khăn, nay lại càng thêm khổ. Tiền của trong nhà có bao nhiêu phải bán hết để có tiền chữa trị. Biến cố ập đến khi bác sĩ thông báo hai chân cô có nguy cơ phải phẫu thuật. Cô gần như đã suy sụp hoàn toàn. Mong ước tưởng chừng đơn giản là đứng dậy, đi lại bình thường như bao người khác, đối với cô Hiền lại trở nên quá xa vời. Đau đớn, tuyệt vọng, cô chỉ biết than với trời. Nhưng ở Hiền gặp lành, ông trời không tiệt đường sống của ai. Trong một lần xem thời sự, cô được đài truyền hình HTV7 giới thiệu về sản phẩm sữa ActiPro giúp giảm triệu chứng xương khớp từ gốc rễ cực tốt. Ban đầu cô do dự vì sợ không hiệu quả, cô quyết định đi hỏi bác sĩ. Bác sĩ sau khi xem qua các thành phần dưỡng trên hộp và nói rằng sản phẩm này cô dùng bình thường, cô yên tâm gọi lên tổng đài được tư vấn. Sau khi biết tình trạng, cô chuyên viên xương khớp khuyên cô sử dụng liệu trình 5 lon trước để theo dõi tình trạng. Ngoài ra vì gọi lên tổng đài nên cô được giảm thêm 40% và tặng thêm 3 hộp 450g nữa. Hợp túi tiền mà lại được tư vấn tận tình chu đáo. Cô hoàn toàn an tâm sử dụng. Cô đặt về dùng thật kỳ diệu. Tình trạng xương khớp của cô đã cải thiện rõ ràng. Cô đi lại nhẹ nhàng, làm việc nhà chăm băm vương tược, thậm chí đi chùa, đi tập thể dục cùng hội người cao tuổi một cách khỏe mạnh.
Khi cô uống vào thì nó phục hồi rất là nhanh. Mà cô chỉ uống mới có 6 tháng thôi mà làm cho người cô khỏe mạnh. Bây giờ đây là hệ xương khớp của cô này rất là khỏe, mà cô vận động, cô làm được mọi thứ, mà cô thấy rằng là ăn ngon, ngủ ngon. Bây giờ cuộc sống của cô hoàn toàn được thay đổi. Cô rất là hạnh phúc mà cả nhà đều vui.
Hiện nay là ở trên thị trường có xuất hiện cái chiếc non ActiPro. Thì đây là một cái giải pháp, sử dụng cái ActiPro thì là một cái giải pháp toàn diện cho người bệnh viêm khớp và thoái hóa khớp, và cũng là cái dòng sữa dinh dưỡng đầu tiên tại Việt Nam có cái công thức dinh dưỡng trẻ hóa xương khớp với thành phần là collagen 2 XS, được bảo hộ và chứng minh lâm sàng tại Mỹ và cũng được FDA của Mỹ chứng nhận là về hiệu quả và chất lượng.
Những cô chú anh chị nào đang bị xương khớp, viêm khớp, thoái hóa khớp hoặc có người thân bị xương khớp mới mắc hay là mắc lâu năm, những ai mà đang gặp các tình trạng như là đau mỏi cổ vai gáy này, đau lan dọc cánh tay, khuỷu tay, các đốt ngón tay bị tê bì mất cảm giác, đau mỏi vùng đốt sống lưng, đau thắt lưng âm ỉ kéo dài trong nhiều tuần, sưng đau các khớp ngón tay, ngón chân, sưng đau khớp gối, sáng sớm ngủ dậy bị khô khớp, cứng mỏi các khớp, khớp kêu lục cục lạo xạo, đau nhức toàn thân, đứng lên ngồi xuống đi lại cầm nắm các đồ vật khó khăn. Thì vào hết đây cháu chỉ cách cho ạ. Sử dụng ngay sữa ActiPro này cho cháu ạ. Đảm bảo là sẽ cải thiện được cho mình các tình trạng là đau nhức này, xương khớp này, viêm khớp, thoái hóa khớp, giúp cho các khớp hoạt động linh hoạt hơn, thoải mái hơn, thiết lập lại cuộc sống bình thường. Đêm chúng ta sẽ ngủ ngon hơn, ăn ngon miệng hơn, da dẻ hồng hào hơn và không còn lo các biến chứng xương khớp cô chú nhé. Sữa ActiPro đây các cô chú ơi, sữa non dành cho người bị xương khớp, đặc biệt là những ai bị viêm khớp và thoái hóa khớp. Nguyên liệu được nhập khẩu hoàn toàn từ Mỹ, ứng dụng công nghệ Mỹ cô chú nhé. Bên trong thì sẽ có thành phần kháng đau, kháng viêm tự nhiên từ sụn ức gà con, nó gọi là collagen thế hệ 2. Và cái collagen thế hệ 2 này thì được y học thế giới người ta nghiên cứu lâm sàng giúp giảm viêm, giảm đau, tái tạo phục hồi sụn khớp và được bảo hộ tại Mỹ rồi các cô chú nhé. Ngoài cái collagen thế hệ 2 thì sẽ bổ sung cho các cô chú anh chị thêm canxi nano này, sữa non này, lysine, đảm bảo cô chú uống vào là các triệu chứng đau mỏi, tê bì chân tay, cứng mỏi các khớp sẽ được cải thiện. Yên tâm là chỉ sau 1 tuần thôi là các cô chú thấy có kết quả rồi nhá. Cả nhà mình cứ uống cho cháu một liệu trình sữa Active Pro này để mình cải thiện được các tình trạng đau nhức xương khớp, viêm khớp, thoái hóa khớp và thiết lập lại cuộc sống bình thường, vận động dễ dàng, thoải mái hơn. Đây là sữa siêu hot, lúc nào cũng trong cái tình trạng cháy hàng nên các cô chú muốn mua sữa với giá tốt nhất, ưu đãi nhất thì tranh thủ mua trong hôm nay đi ạ.
Đã uống Active Pro từ 10 ngày đầu, chúng ta sẽ thấy cơ thể bắt đầu tiếp nhận và hấp thu những cái dưỡng chất đến các bộ phận ở trong cơ thể của mình. Và nhờ những cái thành phần trong sữa như là tổ yến nè, IgG hay là lactium thì mọi người sẽ cảm thấy ăn ngon miệng hơn, ngủ ngon giấc hơn, không còn cái tình trạng trằn trọc, khó ngủ và cơ thể đau mỏi hay là uể oải nữa. Hiệu quả sẽ nhìn thấy ngay sau 10 ngày sử dụng. Chính là nhờ một thành phần đã được thế giới chứng minh tốt nhất cho cái hệ miễn dịch của mình. Đó chính là sữa non 24 giờ từ bò chuẩn sạch organic của Mỹ có trong sữa Active Pro này nha. Việc mình có một hệ miễn dịch tốt và ngủ đủ giấc, nó cũng giống như là cơ thể mình được bảo vệ bởi một cái khiên vậy đó mọi người. Vi khuẩn nè, virus nè hay là các cái tác nhân gây bệnh nó sẽ rất là khó xâm nhập được. Từ đó cơ thể mình mới khỏe hơn, tinh thần phấn chấn hơn, thoải mái hơn. Thì cả ngày mình làm gì cũng không có mệt mỏi. Đi làm, đi chơi hay là thậm chí việc nhà cửa nè, rồi chơi với con cháu cũng vô tư, cũng vui vẻ phải không cả nhà? Và trong 20 ngày sau, giai đoạn này mọi người sẽ cảm nhận được cơ xương khớp giảm đau nhức rõ rệt luôn. Các khớp gối cũng như là khuỷu tay của mình á sẽ không còn bị cái tình trạng tê dại hay là đau nhức mỏi gì nữa hết trơn á. Bởi vì trong cái thành phần sữa non Active Pro có 2 hoạt chất vàng trong điều trị và cải thiện những cái vấn đề về cơ xương khớp. Đó chính là collagen 2XS và aquamin F. Đây là 2 cái thành phần bổ sung canxi và collagen tái tạo sụn khớp vượt trội luôn. Phòng chống cũng như là cải thiện các cái bệnh liên quan đến hệ xương khớp như là đau lưng nè, rồi mỏi cổ nè ha, viêm khớp nè, thoái hóa khớp nè. Đồng thời thành phần myo-inositol kết hợp với sữa non 24 giờ organic Mỹ có trong sữa cũng hỗ trợ cân bằng cái lượng đường ở trong máu, chống tăng đường huyết đột ngột. Và tất cả các hiệu quả này đã được kiểm định và có tác dụng sau 20 ngày sử dụng đều đặn 2 ly Active Pro mỗi ngày thôi nha. Và sau tiếp 30 ngày thì sao ạ? Khi cơ thể đã tiếp nạp đầy đủ và đều đặn dưỡng chất thì chúng ta sẽ thấy là có cái sự khác biệt rõ rệt trong cái việc tăng cường miễn dịch, bảo vệ cơ thể, không lo ốm, đau, mệt mỏi, đau nhức khi thay đổi thời tiết và hạn chế tối đa các cái tác nhân gây bệnh, virus, vi khuẩn, giảm hẳn đau nhức xương khớp, tim mạch tốt, thận gan đều tốt và quan trọng nhất là phòng ngừa ung thư và oxy hóa cơ thể nhờ hơn 40 vi dưỡng chất có ở trong sữa, đặc biệt là lactoferrin cả nhà nha. Và cái việc mình có một cái hệ miễn dịch tốt cũng giống như là có thêm một cái tấm khiên trắng bảo vệ cho mình vậy đó mọi người. Vi khuẩn, virus, các tác nhân gây bệnh sẽ khó mà xâm nhập được. Từ đó thì cơ thể mình mới khỏe hơn được. Như vậy thì mình sẽ ăn ngon, ngủ ngon, tinh thần thoải mái là điều chắc chắn rồi, đúng không nào? Chứ đề kháng hay là miễn dịch của mình yếu thì làm gì cũng không nổi đâu. Thậm chí đau xương khớp nè sẽ ngày càng đau hơn, cơ thể sẽ ngày càng mệt mỏi hơn.
Sau khi dùng được một lộ trình thì tôi thấy cơ thể nó cũng khỏe khoắn lên, tinh thần thấy sảng khoái, phấn chấn lên. Và cái xương khớp của tôi thì nó cũng không còn thấy đau nữa. Mỗi khi trở trời thì cũng không có như tình trạng như trước. Và chân tay tê bì là không có nữa rồi. Đứng lên ngồi xuống thì hai cái đầu gối nó cũng lục cục lạo xạo mà cử động nó rất là dễ dàng. Khi tôi dùng cái sản phẩm Active Pro này thì tôi thấy là da dẻ của tôi nó căng và nó hồng hào. Tóc là không bị rụng nữa mà đen bạc chứ không như ngày trước vì mất ngủ. Bây giờ cái được tăng thêm cái sự miễn dịch rồi cho nên là rất là tốt. Mà không ai ngờ là tôi 70 tuổi. Họ cứ nghĩ là tôi mới có 60 tuổi thôi.
Tôi dùng được nửa tháng thì tôi thấy mình nhẹ nhõm hẳn. Mà đi tiểu là một đêm chỉ có một lần thôi. Tôi thấy sức khỏe nó khác hẳn đi. Và như vậy thấy ngon miệng, ăn uống ngon miệng mà biết đói. Sau khi tôi dùng được một tháng thì tôi thấy cơ thể tôi khỏe hẳn. Và như vậy tay không đau, chân đầu gối không đau nữa. Chân tay tôi rất là khỏe khoắn. Tay tôi mập mạp hẳn hoi. Ngón tay tôi trước kia không cụp được thế này. Nhưng đến bây giờ cụp rất là mềm dẻo.
Ngay bây giờ thì cháu sẽ show giấy tờ để cho cô chú xem phải như thế nào thì Active Pro mới khẳng định được như vậy nha cô chú ơi. Bên tay trái của cháu đây đó chính là chứng nhận FDA và bên này chính là chứng nhận ISO. Còn đây là một chứng nhận hợp tác với tập đoàn Certified Nutraceutical Mỹ nha cô chú nha.
Sữa Active Pro này còn được các chuyên gia đầu ngành tại Việt Nam như là bác sĩ Trần Đình Toán, nguyên viện trưởng Viện Dinh dưỡng Lâm sàng, ủy viên Hội đồng Dinh dưỡng kiểm định và quy dùng. Cho nên là mọi người hoàn toàn yên tâm lựa chọn Active Pro, đồng hành chăm sóc sức khỏe cho mình nha. Nhận hàng thì cô chú được phép mở thùng ra kiểm tra hàng thoải mái ha. Quét mã hiện lên thông tin chính hãng rồi chúng ta mới thanh toán cô chú nha. Trong suốt quá trình mà mình sử dụng á, đều sẽ có đội ngũ đồng hành cùng mình luôn. Cho nên là cả nhà mình cứ yên tâm ha. Chỉ duy nhất trong livestream này, cụ thể khi cô chú mua 3 lon sữa này sẽ được tặng thêm 1 lọ vitamin Arthrosis. Mua 4 tặng 2, mua 5 tặng 3, mua 3 tặng 1, mua 4 tặng mấy ạ? Tặng 2, mua 5 thì sao? Tặng 3. Và đặc biệt khi mua một thùng, ngay lập tức bạn sẽ được giảm trực tiếp 3.480.000 đồng. Quan trọng là free ship nha cả nhà mình ơi. Nhận hàng rồi mới phải thanh toán ạ.
Năm nay tình hình kinh tế nó rất là khó khăn. Tôi biết bà con mình cũng cân nhắc, nhưng mà quan trọng nhất là cái sức khỏe. Mấy tháng trước đi tới đi lui nó khó khăn lắm. Mà uống sữa này mấy tháng nay đó, thấy trong người nó khỏe, nó đỡ đau xương khớp. Đi tới đi lui làm công việc nó thoải mái, khỏi nhờ vả con cháu gì hết. Trong một ly sữa này nè, nó có nhiều dưỡng chất lắm. Bà con mình chỉ cần một ngày uống 2 ly thôi là nó bồi dưỡng cho xương khớp nè, chắc khỏe dẻo dai nè. Đó, đi đứng dễ dàng, làm công việc cái thoải mái. Như tôi nè thấy không, một ngày chỉ cần uống 2 ly sữa này thôi. Đó, sức khỏe thì dẻo dai, xương khớp thì bình thường, không còn đau nhức nữa, không có bị biến chứng gì hết đó nghe. Cho nên bà con mình đó nghe, ai bị khô khớp nè, cứng khớp nè, thoái hóa khớp nè, tê bì chân tay nè, thoát vị đĩa đệm nè, thì uống ngay cái sữa Active Pro này, bảo đảm chất lượng, hiệu quả. Bà con mình nên mua liền đi, đang có chương trình khuyến mãi đó nghe, giảm 40% đó, miễn phí giao hàng luôn. Đó, bà con để lại số điện thoại hoặc là gọi ngay số điện thoại bên dưới đó, mua một thùng giảm 3 triệu đó, đi mua liền đi trời.
Tiêu chuẩn dinh dưỡng của cha mẹ mình, ngoài ăn cơm, ăn nhẹ, tập thể dục là mỗi ngày phải uống thêm 2 ly sữa Active Pro này mới được. Vì ông bà tuổi đã cao, ăn uống kém, cơ thể lại không hấp thu tốt các dưỡng chất như xưa, nên việc bổ sung sữa hàng ngày là rất cần thiết để ông bà có một sức khỏe tốt, ngủ ngon, tinh thần vui vẻ, thoải mái. Cũng như những người lớn tuổi khác, cha mẹ mình thường xuyên mất ngủ, nhức mỏi xương khớp triền miên, ăn uống đắng miệng lại dễ đổ bệnh. Mỗi khi thay đổi thời tiết là cảm cúm, sổ mũi, cả người mất hết sức lực. Có khi phải thức trắng đêm vì nhức khớp gối, đau lưng nên rất khó vào giấc. Thật mừng là từ khi ông bà uống bổ sung sữa Active Pro thì tình trạng đỡ hẳn á mọi người. Ông bà ăn ngon miệng hơn, bớt ốm vặt và không còn kêu ca đau xương mỏi gối như trước nữa. Được cái ông bà rất chú trọng đến sức khỏe, không muốn con cháu phải lo lắng. Nên khi nghe mình nói sữa Active Pro này có bổ sung sữa non 24 giờ, HMO giúp tăng cường hệ miễn dịch cho người lớn tuổi, collagen 2XS và canxi awamin S giúp xương chắc khỏe, phòng ngừa loãng xương, giảm đau nhức, tổ yến, lactoferrin kích thích ăn ngon, cải thiện chất lượng giấc ngủ tốt hơn. Nên ông bà uống đều đặn mỗi ngày, không cần con cháu phải nhắc đâu. Cha mẹ mình rất thích uống sữa Active Pro vì sữa vừa ngon, vị ngọt thanh mà không hề ngấy. Phương châm của vợ chồng mình thì cứ ông bà cha mẹ khỏe mạnh, vui vẻ là mình ưu tiên. Cái gì hợp, tốt, uy tín thì mình yên tâm lựa chọn cho ông bà ba mẹ sử dụng dài dài. Cùng Active Pro dành cho ba mẹ những điều tuyệt vời nhất nha. Cả nhà cùng tham khảo sữa Active Pro này cho ông bà nhé.
Super smooth. Changing belts is done easily by flipping a lever, and the whole belt attachment comes off with this lever. Sweet! One feature I decided against is a tilting table. That's just inconvenient. On my machine, the belt tilts. Much more useful. It's effortless with this lever and clamped with a single knob. There's nothing on the other side, everything done from here, but it gets clamped on both sides. I'll show you later how that works. And the big dust collection part is out of the way in the back. That's everything from the outside. You will never believe how I made the oscillation mechanism inside. But first, let me tell you the stupid reason why I built this machine. Not because of the mechanism. A few years ago, I bought this sander with way too many sanding belts now sitting in storage. And I just wanted a better use for them. Really stupid, but that's the truth. Now, how do you approach such a project from scratch? Where to start? Well, I'll try to summarize. I wrote down a list of requirements with features I wanted the machine to have, like the tilting belt, the height preset, and so on. Then when designing at the computer, I put each feature into its own assembly. So this does the oscillation, this does the tilting, you get the idea. And wherever possible, I try to integrate multiple features into a single assembly. Sounds straightforward, but all that was the hardest part. I spent a lot of time designing. But then you can build assembly after assembly and bring them together. So let's get back in time when this didn't exist and begin with the oscillation mechanism. I've got this precision ground shaft which needs to move up and down together with the sanding drum. A common solution is a geared motor with a crank, but to me that's kind of boring. I wanted to couple the mechanism mechanically to the spinning shaft with a gear reduction. That should be interesting. From my machine specs, I need a gear reduction of 25:1, and I could do that with a worm gear drive. Every turn, the worm advances the gear by 1 tooth. It has 25 teeth, and I've got the right gear reduction. And then I can slide this into this housing, add a crank pin here, and there's the complete oscillation concept. It's a great concept with few parts, but 3D printed like this, it can't survive long term. This has to be metal and constantly lubricated, so I would need to find just the right one off the shelf or have it custom manufactured. That's not gonna happen. So another mechanism with a high gear reduction is a cycloidal drive. And if you ask yourself what that is, take a look at my logo. That's a cycloidal drive. Conceptually, it's simple. We have a housing with pins, the shaft with an eccentric cam, the cycloidal disc, and an output ring. The shaft goes in the housing with the cycloidal disc on top, and when I spin it, it does this kind of motion. The output ring fits on top and turns that wobbly motion again into a smooth rotation. The gear reduction is the amount of teeth of the cycloidal disc, so in this case 9:1. This concept I'm sure I can make reliably lasting with simple off-the-shelf parts and 3D prints. And so now we've got a fast spinning shaft and a slow spinning gearbox, but no oscillation yet. On this concept, the output gear is oriented 90 degrees to the main shaft, making the crank possible. And I still need that for this one. Bevel gears, for example, could do that. But again, I don't see them lasting a long time. So what else could create oscillating motion? Let's start simple with this ramp shape. If I move this back and forth, you can see the intersection here is moving up and down. And I could pick that up with a bearing. Now let's mirror that ramp, and the result is one up and down motion without changing directions, or rather one full oscillation. But how is this helpful? Well, when I wrap it around a cylinder and make it spin, I now get continuous oscillation. And what actually matters, this cylinder is the same orientation as my gearbox output and a single part. No need for bevel gears. So I think we have quite an elegant solution here and can get serious making the real version. Getting serious means a lot of 3D CAD work. I modeled the entire assembly with every component before I ordered parts or started printing. But here we go. There are many printed parts, a few bearings, pins and screws, and machine parts, which I need right now. So I cut off pieces from some tubing. The longer bushing goes on first with a washer and screw as an end stop that I have to play with, of course. Let's put that aside for now. Now the gearbox housing. The pins this uses are actual steel pins that fit in these holes that I still need to ream. The automatic compressed air comes in real handy here, removing the chips. The underside then gets a bunch of nuts pressed in, as well as a few on the inside. I could have also used the CNC Kitchen melt-in threaded inserts, but what they don't have is a plastic lock ring, and since I'm expecting vibrations, I wanted that. This bearing is a light press fit in the center, and this ring goes on top, clamping it down, making this my fixed bearing. The large bearing fits around the housing, where it first slips down easily, and the last little bit is again a light press fit. And then insert all the pins. Next I need to make sure the cycloidal disc is sized correctly and moves freely in the housing. So when I put it in place, it should just drop down. But it doesn't, and I have to press it down. It does move, but it's pretty tough. I kinda expected this here, because I designed and printed this with no air gap, and when that's a real mechanical part, it's basically guaranteed to bind in some way. I need some amount of air gap in here, but just don't know how much exactly, so let's find out. I printed 5 discs with increasing play for testing, starting with 0.05. And it already drops down, but the movement is still kind of rough. 0.1. Yeah, that's a bit better, but there's still some places where it feels like it's binding. 0.15. Yeah, now it's getting better. 0.2. Yeah, that's great. And 0.3 is probably no improvement, just more play. Here you can see the play. This is 0.05 and this is 0.3. 0.2 seemed to be the sweet spot. Let's go with that.
A bearing gets pressed in, followed by steel bushings in all the holes, which came in an interesting packaging. And then a second one. But before the discs came another ring first. It has some holes to ream, nuts to press in, a center bearing, and then the output pins, because this is part of the gearbox output and it sits below the cycloidal discs. Now the parts can come together on the shaft. First the housing, then one of the spacers, and the output ring.
Next come the eccentric bushings that create the wobbly motion.
Their center hole needs to be reamed as well.
Then I have a feature in them which positions them opposite to each other like so. To fasten them on the shaft, there's a pocket for a little square nut and a tiny set screw. And now the disc. Wait. Ah, crap. I forgot to file flats on the shaft.
And disassembly is not as straightforward.
Yeah, at least I didn't forget to mark where to put the flats now.
Since the steel is hardened, I'm using a diamond file and it bites into the material well. But there has to be a more accurate way of doing this. I put 2 square blocks at the ends and this piece which holds the file parallel and at the right height. No need worrying about steady hands. But the real benefit is the second side, because I just need to flip the shaft and the second flat will be at a perfect 180 degrees to the first. Simple technique, but great results. The other flats are for later. Now I'm much more confident in the set screw and the cycloidal disc can go on top. I was really keen on testing, so let's do it.
This looks nice.
So now the second disc.
I need 2 discs because having only one wobbling around would vibrate. So having a second one opposite to the first one, the vibrations will cancel each other out. But I have to make sure the second disc is oriented correctly to the first one in the housing. Otherwise these output holes won't line up with each other. Since I have 12 output holes and 25 teeth, this is not symmetrical and there's only one correct position. So I put a little notch at one of the holes to make this simple. Right here. Looking straight down, you can now see how the holes of both discs kind of do a circular motion around where the output pins will be.
So let's put them in.
That looks promising. The remaining 3 holes are for screws.
And after reaming the pinholes in the lid, it goes on.
On top now goes the actual gearbox output with matching holes, and on the outside there is the integrated ramp, which I made a lot smoother, and it also fits a bearing.
As usual by now, reaming the holes and pressing in a bearing, then the last spacer washer, and then assembling all the parts together. The screws hold everything together, but I have to tighten them by feeling, and this is my by feeling phase. Without context, this looks really stupid. And finally, a dust cover with an improvised labyrinth seal.
Oh yeah, that's the gearbox done. What a nice little compact unit, basically full enclosed and protected from dust, which is nice. It's super smooth. I can't really feel resistance other than the 6 fresh bearings. And what you might not expect is this is back drivable, which means it works when I spin it here or here. That's cool. Just too bad you can't really see the inside now working. Let's fix that. There you go, I cut it open. Let's see it in action.
So for this short sequence, I had to disassemble everything again, but this then at least allowed me to add grease when reassembling.
But still, can this survive long term? Because it will run a lot. Well, I'm confident because all the motion is either done by bearings, metal on metal, or at least well-lubricated plastic on metal contact. And even if that's still not enough, I've got one more trick up my sleeve. Because thanks to the sponsor of this video, JLC 3DP, I've got all gearbox parts and some more for later printed from nylon, a much tougher and more suited material than PLA.
Other manufacturers also know that. For example, this gear in my planer gearbox is also made from nylon. While we're in here, let's clean it.
And look at the print quality. That's just nice.
Much better than what I could achieve. And ordering these parts from JLC is pretty simple. If I print them myself, I export the 3D model and import it into my slicer software. For the order, I just upload the same file to JLC 3DP. Here I could then choose the 3D printing technology, in my case SLS with nylon, the amount, and I instantly get a quote.
For example, 2 cycloidal discs are just $6.50.
Just like my own parts, all these of course also need some reaming before assembly, but then they pretty much go together the exact same way.
And there it works. Nice. The heart of my machine. If you need custom parts, give JLC 3DP a try. Their printing service starts at 30 cents, their CNC machining service starts at $8, and if you use my link in the description, you can get a $60 coupon. But for now, let's disassemble it again, because until the final assembly, I want to stick with my parts, because I of course want to see if they work. The next part that goes on the shaft is the pulley.
It's made from the pulley and the pulley support, and starts out as this chunk of aluminum. This first gets a facing cut and then turned to size with a few roughing and finishing passes and a chamfer. It's a non-critical dimension, but still nice when you hit the 45mm exactly. I used a 3D printed template for transferring the hole locations and then cut the piece off, but forgot to record. It could have looked like this. Except the diameter is too large for my tools, so the last bit is for the hacksaw. A quick jack jaw swap to clean up the second face, and then heading to the drill press for the threaded holes. Spot drilling, chamfering, and threading. Standard procedure. For the set screw hole, I installed 2 screws that position the piece correctly in the vise, and with the ruler method I made sure the part is centered. Then I carefully spot face with an end mill and do the rest. For now, this piece is done. The pulley starts as a scrap of polyethylene sheet, which I placed on the CNC router to cut the screw holes and a slightly oversized circle. Cut out, it goes in the chuck where I marked the rough size of a pocket, which I turned to a snug fit with the pulley support, followed by chamfers and removing this material, which creates very fluffy shavings. Then the pulley support goes back in the chuck where I faced it one more time and then screwed on the pulley with a dab of Loctite on the bolts. I turned the diameter to size and sharpied it black to better see what comes next. Finding the edge with the tool, move it to the center, scratch the surface and zero the dial. Then plunging to a certain depth, creating the V-grooves for the belt and breaking the sharp edges. The last feature is a precise center hole, which I drilled and then carefully turned to size. It took many passes, but I hit my target and the result is this.
Ah, perfect. Alright, next comes the upper bearing block.
The upper bearing sees more of the load when I'm pushing against the sanding drum, so I made the bearing housing from aluminum. Here I marked the side centers, which helped me to position the piece at the correct location on the machine bed. There, I first machined the holes that align with my hole grid, so I can use 2 bolts to hold it down, and then I let the machine go to work. The finishing pass is really satisfying, as well as the chamfer. Turned out really well, but right now the bearing doesn't fit, because the CNC is not accurate enough for a bearing seat. And I want to turn that, so somehow I need to hold it on the lathe. I've got some round offcuts from a laser, that should work. I marked the center and the whole spacing of the two hold-down holes, which I then quickly turned into threads. With a magnet on each jaw, the plate has just a little bit of stick out. I face it by leaving some material at the center, and after about 1 mm, I turn it to a nice fit with the aluminum. That puts it in the perfect center, and I can hold it again with bolts. I left myself about 1 mm of material so I can do multiple passes and get it accurate. And I think that paid off. The result is spot on. Then turning the hole to final depth. At the drill press, I drilled and tapped the outer holes to M6 and the inner holes to M3. But since they are blind holes, I finished the threads with a drill and a low clutch setting.
The bearing nose should be a light press fit. And it's not. Oh, fuck.
Turns out the bearing is also slightly undersized, which I should have measured before. But at least I can now try out a trick my dad told me. A layer of Sharpie. It's a few microns thick and should solve the problem.
Oh yeah. That's a press fit now. Nice.
And the 6 screws hold it in place.
The last part that goes on the shaft is the drive block thingy that engages with the sanding drums.
It's straightforward and similar to the pulley support. I face and turn some stock to size so it again fits the template, chamfer it and cut it off. This time with recording it. Flipped around, I face it to length and then drilled and turned the hole to the same fit as the pulley. Then transferring the hole positions, drill and ream them to size and depth, and hammer in some pins, which will engage with the sanding drums. They also line the part in the vise for the M6 set screw hole.
Very nice. Everything is mounted, but it's far from being a finished sander. This needs to be mounted in something, and I call that the sled.
The sled basically is a wooden box where all parts have different features cut into them, and after a bunch of toolpath programming and flattening the CNC bed, I can begin. The workhorses are these single flute bits in different diameters. They allow me to take aggressive cuts and remove a lot of material. But first I have to prepare my material. Some 18mm thick birch plywood, which I cut into roughly oversized pieces, and then cut a shallow groove all around for my hold-down clamps. This gives me access to the whole surface for machining. But mostly the stock material isn't flat to begin with, so I shim the gaps to not bend apart with the clamps. I then cut the various holes and other features into the part, followed by the outer contour to about half the depth. Then I switch to the flattening bit to make the surface flat and also cut away all the burrs from previous operations. And then the program waits for me to switch to screws to finish the outer contour. And like this, I cut all the parts. Some I also just tapped. And of course, I also had to crash into the shim, destroying this brand new bit. At least I can continue, so I removed all the bigger chunks, flush trimmed the edges, and made new grooves for the second side. I then used pins to precisely position the parts for the second side. That works because I have the same whole layout in Fusion 360, so the software position and the real position match, and I don't even have to probe the parts. Most of the second side operations are holds, chamfers and big chamfers, and flattening to thickness. Basically the same for every part. And there are all of them finished.
And none of these parts are sanded, but by using the right techniques and especially order of operations, I get these clean and sharp edges everywhere on both sides. Let's check the fit. Ah, beautiful.
Before assembly, I inserted a few nuts and some steel pieces that I first needed to make. However, straightforward. They will be used later.
I'll do the assembly here on the table saw, because I know this is a flat surface, starting with the back and middle piece. The bottom edge needs to be flush, and then I can transfer the holes.
All these screw joints got a clearance hole using the existing holes as a guide, then a pilot hole, and then a screw. That way the drill bit doesn't wander in the plywood edge.
Then the top plate flush with this edge.
the left and right side, but they needed to be clamped in position. Lastly, this bottom piece, but it seems to be just a hair too wide. So that's the sled skeleton almost complete, and because of the way I designed this, all the pieces are kind of squaring up each other, making this a square block all around. With it all together, I could remove a few screws again and replace them with the dowels to make it a more permanent connection. Next came two pieces for the motor mount, except they didn't require the CNC router, and then they got bolted on with the nuts I previously installed. Then I made these angled pieces that close the gaps between the top and back plate and glued them in place. With the glue dry, I flush trimmed all the dowels and then cut a large bevel, which is for clearance when tilting. That's the finished sled frame. Let's add components to it. The gearbox with belt goes in here, where the housing gets bolted to the bottom, the bearing block to the top, and the motor goes here. Yeah, what motor? I've prepared something for that. I picked up this crappy little table saw for free from the garbage, where it belongs. I mean, I'm terrified of this as a table saw. But it has a nice little motor. I just need to free it from all this terribly dangerous table saw crap. And there it is, freed from the pile of scrap metal. Nice and quiet, 700 watts and 2800 RPM. That's great. The capacitor and wiring I'll mount elsewhere, so the motor really is as compact as possible. Something strange though is this. A significant rubbing noise coming from the back. So I took off the back cover and couldn't believe it. There are two pieces on the fan that are intentionally rubbing on the housing. Why? Was this supposed to be a motor brake for the table saw? I don't know. Let me know what you think in the comments, but this will go. Even spring-loaded. Now right here on the shaft needs to be a flat spot for the pulley set screw. I could hold the shaft in place with vice grips and use a similar file contraption as before. Only this time the shaft isn't hardened, so I could use a normal file. The rest of the shaft is too long and I also don't need it, so off it comes. I then let it spin to clean the end and chamfer it before I started working on the motor mounting brackets. I cut them from some steel flat stock. Another job for the big ass file, getting the length right until they fit in the sled. Then I transferred hole positions, punched them and drilled them. For the slots, I drilled multiple holes that slightly overlap each other, so I could fit a jigsaw blade to remove material, so I could fit a Dremel to remove material, so I could fit a file to finish the slots. Not my best work, but the slots work and that's what counts. Then I transferred hole positions again, drilled pilot holes and added screws. I couldn't reach the top screws, not even with a driver bit in pliers, so I opened up these holes and used hex head screws. Now that's a solid mount to bolt the motor to. Well, I've got a problem. I cannot get these back screws installed. There's just so little space, and I knew this would be difficult. I can get them in place, but then just can't get the thread started and the screw jumps around. And the pulley isn't even installed yet. I don't want to drill access holes in the top because I wanted that closed off. Yeah, but I have an idea that might work. With a threaded piece, I can hold the bolts in the lathe chuck and work on the threads. I had to shorten them a bit and then remove the threads of the first couple millimeters. So now the screw can fit in the hole and stays in place, making it much simpler getting the thread started. Then I also realized I could remove the front support for more access. Nice. And the threads are in. Alright, now I know how I can mount the motor and can continue with making the pulley. It's relatively simple and starts from this piece of aluminum from before. First facing, turning the major outer diameter and the step to size. Then I again mark the surface to easier locate the edge and the starting depth. and then turned the 3 slots just like before. Here I also broke the sharp edges with a file. And lastly comes the hole. I first removed most of the material with a drill bit, then measured the actual motor shaft and turned the matching bore. Checking with the motor, and that's good. Flipped around, I could part off the rest, or at least that was the plan. Luckily, only a static damage, and I could continue. Everything left is facing to length, turning the second step, deburring the hole, and making the threaded hole for the set screw. For the wiring, I 3D printed this custom lid. It fits one of these cable clamps. The capacitor has its place here, with the wiring going internal through this hole. And when it's assembled, the hole will line up with this one that I need to open up. Not only that, but also cutting through the top. Then I finished up the wiring, gave it a test spin, and closed the lid. That turned out nice. Another addition before testing the gearbox with the motor are 2 bearings on top of the gearbox output. They are the axial support and will take load away from the other gearbox bearings. But having just a plain bearings on top didn't work so well and was wearing the surface quickly, so I printed these cover parts from TPU, turned and chamfered them and pressed the bearings into them, like wheels. That's better. And back to the motor. I spent some time installing it back in the sled, got the belt on the pulleys and tensioned it. It's also important for the pulleys to be aligned to each other, which I could adjust and check with a bore gauge. And now it's ready for the first power test. It works. Woohoo! What a strangely soothing and satisfying motion. Very nice so far. Now I will remove everything again, because moving forward it's easier when there are less parts and weight. For the sliding hardware I'll be using a linear rail with 2 blocks, because this set is with just about 40 bucks pretty unbeatable. The blocks have 2 precise surfaces, one where it gets mounted and one here that runs parallel to the rail. And to get them aligned on my sled, I've machined 2 holes for pins where I can slide them against. Mounting them to wood isn't really ideal, but at least I've all the surfaces machined. And here I thought about access holes. That's the sled finished. Next, it again needs to be mounted in something, which I call the carriage. It basically is another wooden box around the sled where it can slide up and down in. It also holds the mechanism for raising and lowering the sled, and later the components for the tilt feature. Just like before, I prepared all parts for the CNC router and let it do some magic, like this. Or this. How about this? And that. Or this. And then all the other sides, as well as some manual work. These are all the parts, and the assembly is quite similar to the sled. All the hexagonal holes receive some nuts. 2 holes get threaded for a screw that will later be an end stop. The smaller parts are bushing and bearing housings, and then there are again alignment pins for the linear rails. The assembly starts with these 2 alignment angles in the side piece. And like before, everything gets a pilot hole and a screw. They are the alignment and square reference for the front. And now this is nice and square. Next is the back. And the other side on top, so I can clamp at the bottom. Then the bottom, which also squares up the back. And finally the second side, which now has lots of alignment surfaces. Alright, that's the carriage assembled, and I now need to check if the sled with rails attached fits inside here. And it fits. Nice. Just a little bit of friction and it's not getting tighter. Oh yeah. Seeing this work is so satisfying and quite a relief, because there's already a lot of time invested here. I slid the rails against the pins and screwed them down. The 2 rails should now be parallel to each other, but we can also check that. with a dial indicator mounted on a block. About 1/10 of a millimeter variation. And against the face, it's a little over 2/10. If I'd be building a CNC router for steel, that would be terrible, but in this application, where also the frame is wood and not that stiff, that's perfectly fine. And knowing that, I could replace some screws again with dowels, holding it together for good. While that's drying, I can start working on the assembly that will go here, that interacts with the slot in the gearbox, and also allows the raising and lowering of the whole sled. And when you look at the available space left, this had to be very compact. Conceptually, there needs to be this bearing mounted rigid, so the gearbox can push the sled up and down from it. And additionally, I need to be able to move the bearing up and down. The very first concept I had in mind, I guess could have worked, but I'm glad I scrapped it for this one. There are some steel parts that I took care of right away. First a pin, so lathe work. Relatively simple part, first facing the end and making the M5 threaded hole with just a little bit of lubrication. Then turning the outside, the overall biggest diameter, then the 12mm part, a bit less for the M12 threads, and then the 8mm section for the bearing. Then adding a lead-in chamfer for my tailstock threading die holder I built last year. What a great little tool. And after that I could cut it off. But something seems wrong. This doesn't match the drawing. I forgot to add the thickness of the cutoff tool. Starting over is so much fun. But now I could chuck it the other way to face it to final length and cut the M8 threads. In the vise I filed the wrench flat, and this part is complete. Next is a plate for which I could use the offcut from before. I just needed to bring it to length, mark the hole location and drill it. Lastly, another plate that I cut and sanded to size so it fits the cutout in the carriage. For the slot I used a step drill, removed the middle with a jigsaw and filed the rest. Perfect. Okay, I need one more part from the CNC router to demonstrate the concept, and like the gearbox output, it also has a ramp. This material is not wood, it's called HPL and it's kind of a mixture of wood fibers and resin compressed together and with a pretty hard and durable surface. It's also weather resistant and dimensionally stable, but I can easily machine it with woodworking tools, thus making it a very suitable machine part. This gets bolted together, then in the slot, and the ramp on top, and the bearing. And now as I slide this left to right, the pin slides up and down. All this now just needs proper guides so it's solid and works smoothly. My material choice are sheets of polyethylene, which are dimensionally stable with low friction. I could use the same hold-on techniques from before and also use my woodworking tools, just a bit less aggressive. Great camera placement. In general, quite an easy material to work with, but the chips can get pretty annoying sometimes. Now with this cut and still clamped, I can check if the depth of the step is the same as the thickness of the slider. And I can already feel and tell that's not the case. 6.34 for the thickness and 5.98 for the step. Let's fix that. That looks good now. And with the lid on top, it can still slide freely with little to no play. Some more features for the other side, and onto the smaller guides, which are basically the same, but simpler and with additional manual work. And there I've got 6 nice parts and 1 glorious fail. One of the guides for the metal plate was supposed to be aligned square with pins, but something obviously went wrong there, and this won't be helpful. However, the hole in the backing plate is accurate, which I can use as a pivot and then align it with a square. Did I just say 1 fail? I meant 2. That's better. Nice and smooth and very little play. The pin got an acrylic glide bushing, which I machined to a perfect slip fit and reamed the hole. The acrylic is hard, has low friction and had just the right thickness. Then a lock nut to secure, but not tighten it. The other guides received some nuts before the installation.
What? Ah, great. The holes don't line up.
And the drill doesn't fit, so guess who spent some quality time drilling holes by hand? Me having to watch this again is just as painful.
Okay, now the next problem. The slider doesn't fit.
At least that's an easy fix with some precise table saw cuts.
Perfect.
Then just adding the lids and the bearing.
Wow, that took quite a while, but now it works smoothly. The bearing feels solid with little play. That's good. Next is the hand crank coming out the side to control the height,
which involves all these parts. This 3D print receives some nuts and gets screwed to the slider. This little trapezoidal nut needs to be flat on one side and gets mounted to the slider as well. The little bearing flange from before gets screwed to the outside with the threaded rod right through.
The nut is just a little snug and still moves, which allows me to now align it with the spindle axis and then lock it in that position.
Next I turned a tip to one end, which I could use to transfer the right hole location into the guide rail. It's hard to see on camera, but there needs to be a hole for a tiny brass bushing. So turning some brass to a light press fit and then the hole, which I started with a 6mm end mill and then used another end mill in a bushing, in a bushing, in a mount, in a tool holder as a tiny boring bar, and that worked pretty well. The remaining wall thickness here is just 0.25mm, but it worked.
With everything back together, the threaded rod should now just fit in the bushing. And it does. Nice. This now allows me to pull the slider towards me, and to push it, I have this adjustment ring against the bearing, with access to the screw here. Very nice. And lastly, the hand crank. It's a 3D print and I'll mount it with one of these clamping rings that I drilled 2 threaded holes into. The shaft is still too long, but I'll shorten this later, because now I want to see how and if this works together with the sled.
That's an extremely important test, since the whole sled weighs 10 kilograms. So as an afterthought, and just in case, I'm installing some gas springs.
Alright, and there I should get oscillation. Oh yeah, it works! Okay, and now with gravity on, lifting 10 kilos. It's pretty smooth. Nice. Isn't this amazing? That was without the gas shocks, all the weight just on the gearbox.
So let's hook them in and try again.
Well, I can't tell much of a difference here, but the hand crank. Oh, that's now so easy to crank up. That's without the gas shocks. And that doesn't sound nice. And now, of course, with the motor. Oh yeah. Nice. Now that's a huge milestone, but next this, once again, needs to be mounted in something. And I call that the trunnion assembly.
Yet another wooden box, and it's what allows the tilting motion, and is also the machine base that holds everything together and will later also carry the table and dust collection. The most interesting parts to start with are of course the trunnions, which I again make from polyethylene sheets, but thicker. It wasn't flat to begin with, so I shimmed and flattened it before the actual machining. But then it's not much different from other parts so far. So cutting holes, chamfers, flatten it to thickness, and mount it with screws for the contour. Once done, I checked the trunnion width, and since it came out right, I could already cut away the remaining stuff, position it with pins to remount it, and cut the second side to finish it up. But eventually, the camera was tired. A clever detail is that the holes I used for positioning on the CNC bed are now also used for positioning the part on the carriage. Everything has a purpose. Then just making the second one. And this one has a little bit of a flexible section. There's this tapered hole where, for example, a screw head can spread this slot open, which then wedges the trunnion in place. The actual piece, of course, won't be a screw head, so let's get that made. A slightly more interesting lathe part, starting out simple with a threaded hole. Then I turned down the major diameter and the smaller end to finish dimensions, and scribed where the tapered section needs to end. Then I set the compound to 15 degrees and whittled away the material up to the scribe line. Going by eye is accurate enough since I added enough clearance on other parts. And it seems to work, so I smoothed it out a bit, cut it off, and went to the disc sander for the flat. That's necessary to properly start the hole for the pin that gets hammered in place and will prevent the cap from spinning in the hole. These are done, so next are their matching parts, which are also the machine base sides and the most complex parts to machine. That's because after machining the first side, I needed to take it back to the bench and glue on this additional part. Well, in terms of complexity, that was mostly the programming. There are just lots of operations on this part. That was the roughing cycle, where this roughing bit made a super nice job of creating tiny shavings that basically never clog it up. Alright, the machining is done, and if everything went well, this should now not fit in the slot. And it doesn't. I intentionally made this too small at first, so I could now sneak up on a good fit. And a little problem, because I didn't surface at the end, there's a lot of fuss going on, so I ran the chamfer bit along these edges to clean that up. And that is pretty nice. And there's the second one. Let's test if that clamping feature actually works. So now it's loose. I give it a little spin. And it does. Oh yeah, that's tight. I have not tested this before. If that wouldn't have worked, I would have been kind of screwed. But I also couldn't think of a way why this shouldn't have worked. But I'm still glad it does. Oh yeah. Ah, that's great. You've probably also spotted these integrated gear teeth, which in combination with a small gear allow me to precisely adjust the angle with a lever. And in addition to the gears, I also turned some gear mounts, very similar to the pulley support, with a simple reamed hole, 3 threaded holes in the face, and 1 more for the set screw. But to try all this out with the carriage, I first need to assemble the rest of the base. And that is the bottom plate and 2 support ribs. They again got nuts inserted and 1 threaded insert where I tried the drill press. Nice. And then again, it goes together like a simple puzzle. The 2 ribs go into the bottom plate first, providing alignment and square reference for the sides, which can then be clamped and screwed together. And there's your 5-part 3D puzzle complete. Only thing left now is mounting the trunnions to the carriage with the gears already in place, the 2 bushing blocks inside, and temporarily securing the taper cap. Alright, and now for the first time I can try to fit the carriage in the base, which I have to do like this. Oh, and it fits. Nice. It's also very smooth. There's also a small air gap here and here, so the carriage doesn't rub on these surfaces and only glides on the plastic. The gears are still free to move, that's good. And the whole carriage by design has about 1 mm side-to-side play for clearance. And when I lock it at some angle, it will always get pulled towards this side, removing the play, while this trunnion then just wedges itself secure. So next, I can get the gears functional. And that's done with a shaft going all the way through to the other side, tightening the set screws to it, and remove the subtle gear backlash with the bushing blocks. The handle is similar to before a clamping ring that I cut threads into, and a 3D print, but this time it's more of a lever type handle because you do less than a full rotation with it. And there it works, nice. I wasn't sure, but this feels like a good size for my hand, and with the gears I can be super precise with the adjustments. That's nice, but how to lock the angle now? Well, you've maybe seen that this shaft is actually a tube where I can now stick a threaded rod all the way through. The end will find the threads of the tapered cap. You can't see but hear it. When I'm turning left, there the last thread skipped, and now I can thread it in. Now I just had to bring the parts to the right length, so all this can work. I also reduced the diameter where the set screws mangle up the surface, so the tiny burr doesn't protrude past the main diameter. With 2 nuts, I could tighten the rod into the tapered cap, then the handle with a washer, another washer, and the knob. So now I can set an angle, give this a few turns, and it's locked on both sides, all done from here. That's what I think is intuitive and easy to use. Later in the build, I made this even better, because with the weight of all components, setting an angle was getting pretty hard. So I installed 2 gas springs that made a huge improvement. Much better. Of course, we also can't forget about an angle gauge and a pointer that mounts to the trunnion with a little stud. The base as open box with the 2 ribs right now is pretty strong already, but obviously not enough. So to act on that, I glued together a solid hardwood beam as a structural member, which I then milled square, cut to width, and set up the bevel cuts. This may look a bit sketchy, and I wasn't 100% comfortable with the offcut sliding down the blade, so my dad hit the emergency stop as soon as the cut was done. Then only cutting it to length, which I screwed up and had to go through all this to give it another try. That's more like it. The piece also got some holes for mounting the table, and with some setup work for the counterbores, and a counterboard hole in the middle for the end stop bolt. Yeah, don't ask. I cut a few threads with a tap and forced the bolt through the rest, making it very tight. Now let's mount it. I transferred the whole location, but will drill the pilot hole with a slight offset so the screw will really pull it in place. There you can see the offset. With that in place, I can install the 90-degree end stop and the 45-degree end stop, the bolt in the front beam, with both of them now being metal-on-metal contacts. And there I've got a big structural piece with integrated end stop, and it will also hold the table, which is next. And as you might guess, it also has features and won't just be a simple board. It's made from multiple pieces, and depending on which sanding drum or belt is used, has different table inserts. First of all, the sub-table that holds everything together. Another CNC routed part, and after the first side is done, I check the groove for the C-channel rail, which needs some adjustment. Difficult to see on camera, but it's a better fit now. Then with the second side done, I can align the C-channel flush, mark the other end, cut it off, and sand it to the line. Would be a perfect job for an edge sander, you know? I also drilled 2 more mounting holes because only 3 seemed not enough. The material below the C-channel got quite thin, so it got a reinforcement piece that also gives the C-channel screws a lot of meat to bite into. The actual table surface plates are made from the same HPL sheet like the slider or gears. That killed yet another bit. God damn it, I was too optimistic again. Let's better go on with some manual work like reaming 2 holes and chamfer the edges. Next, I needed some steel brackets, but the right width was out of stock, so I cut a wider piece in half.